Hello friends, welcome to HP Development Academy. In the last lecture we have discussed up to question number 6, so we will discuss question number 7 onwards in this particular lecture. So basically we are discussing the problems on the concurrent forces. Okay, so let's start our discussion. So before proceeding further on the discussion of these questions, let us go through the concepts that are required for solving such type of questions. Okay, so let us go through those concepts. Okay, so we have the concepts as the first one is the circumcenter, second one is the orthocenter, and third one is the incenter. Okay, so the circumcenter of a triangle is the point where the perpendicular bisectors of the sides of the triangle intersect. Okay, so it is also the center of a circle that passes through all the three vertices of a triangle. Okay, and that circle is known as circumcircle. Okay, so we have a triangle like this. Okay, and we have the perpendicular bisectors. Let us draw the perpendicular bisectors. By perpendicular bisector means this bisector divides the side into two parts. Okay, similarly this one, this divides it into two parts. This is the perpendicular bisectors. Okay, so the point where these perpendicular bisectors intersect, the point where the perpendicular bisectors intersect is known as circumcenter. So this is our circumcenter. Okay, it is also the center of a circle that passes through all the three vertices. So we have the vertices as A, B, and this is C. Okay, so this is the center of a circle that is passing through all the three vertices. Okay, so let us draw the circle like this. Okay, so this is our circle and this is the point. Okay, so this is the circumcenter. Okay, now we have the concept here is that let us take this as angle A, this is angle B, and this is angle C. Okay, so the angle made by the side of a triangle on circumcircle. Okay, so let us consider angle made by BC on circumcircle is equal to angle A, and angle made by side BC on center is equal to angle B, this is O, the center is O, BOC. Okay, so we have the relation as angle A is equal to half of angle BOC. Okay, so the angle made on the circumcircle is equal to half of the angle made by that side at the center. Okay, so this angle is BOC, angle BOC. Okay, and this is angle A. So the angle A is equal to half of angle BOC. Okay, now let us discuss orthocenter. Okay, so we have the orthocenter as the orthocenter of a triangle is the point where triangle's three altitudes intersect. Let us draw the triangle. This is our triangle. Triangle's three altitude intersect. So let us draw the altitude from the vertex. So this is A, this is B, and this is C. Let us draw perpendicular from the vertex. This is perpendicular. This is our perpendicular. Okay, so these are the altitudes from the dropped from the vertex. These are the altitudes dropped from the vertex on the opposite side. Okay, so the orthocenter is the point where this is our orthocenter where the three altitudes intersect. This is our orthocenter. Okay, let us discuss about the incenter. The incenter of a triangle is the point where three angle bisector of a triangle intersect. Let us draw the angle bisector. So we have a triangle like this. Okay, so these are the angle. Okay, Let us draw the angle bisector. So this is our angle. Okay, so let us consider this as alpha. Let us draw the angle bisector like this. So on bisecting this, this will be alpha by 2 and this is alpha by 2. Okay, so let us draw extend the angle bisectors. Okay, so this is our in center. So in center of a triangle is the point where three angle bisector of a triangle intersect. Okay, so the angle bisector intersected this point. So this is known as in center. It is also the center of a triangle's inscribed circle. In circle, the in center is always located within the triangle. So let us draw a circle keeping this as a center. Okay, so this will be like this. This is our in center. Sorry, this is our in center, and this is in circle. And point here is that in circle always located within the triangle. Okay, so these are the concepts that are required for solving such type of questions. Okay, so the in center. Okay, so once we draw the in center, so there are three triangles. Okay, this one, this is first one, this is second one, and this is third one. Okay, so let us name this. This is A, this is B, and this is C. This is O. So first one is triangle AOC, and second one is triangle AOB. Third one is triangle BOC. Okay, so this area of these triangles are equal. So angle area of triangle AOC is equal to area of triangle AOB is equal to area of triangle BOC is equal to half of area of triangle ABC. Okay, so these are the concepts that are required for solving such type of questions. Okay, so let us solve this one by one. Okay, let us discuss the questions. Okay, so in the first question we have a ABC is the triangle. Forces PQR acting along the lines OA, OB, OC are in equilibrium. Prove that if O is the orthocenter of a triangle ABC, then P upon A is equal to Q upon B is equal to R upon C. So how we can solve this? So we have a triangle ABC. Okay, and we have O is the orthocenter. Okay, so the orthocenter of a triangle is the point where the triangle's altitudes intersect. Okay, so we have, let us draw the altitude from the vertex. So let us name this as A, B, and C. Let us draw the altitude. Okay, so this is our orthocenter. So this is angle, this is angle B, this is angle A, this is angle C. Okay, so let us take triangle this one. Let us name this as D, E, and F. Okay, so let us take triangle BCF. Okay, so triangle BCF. Okay, in triangle BCF we have, in triangle BCF, this is 90 degree, this is angle C, and let us take this as alpha. Okay, so this is 90 degree, so alpha plus angle C is equal to pi by 2. This means alpha is equal to pi by 2 minus angle C. So this is equal to pi by 2 minus angle C. Okay, now let us take triangle BEC. Okay, let us take triangle BEC. So triangle BEC. Okay, triangle BEC. Let us take triangle B, E, and C. So this is B, this is E, and this is C. So this is 90 degree. Okay, so this is our angle B. Similarly, see this is 90 degree, so this will be pi by 2 minus angle B. Okay, so this is pi by 2 minus angle B. Okay, so now let us consider this triangle. This is O. So let us consider B. Let us consider BOC. Okay, so we have the triangle as this one. This is B, this is O, and this is C. Okay, so we have the angle as, so this angle is pi by 2 minus angle C. This is pi by 2 minus angle B. So this will be pi minus sum of these two angles. So pi by 2 minus C plus pi by 2 minus B. Okay, so we have, from here we have pi minus, this is pi by 2 plus pi by 2, this is pi minus B plus C. So this is equal to pi minus pi plus B plus C. Okay, so this angle, so this is equal to angle BOC. So angle BOC is equal to B plus C. Okay, and we have angle A plus angle B plus angle C is equal to pi. So from here B plus C is equal to pi minus A. So this is equal to pi minus A. So this angle is equal to pi minus A. Okay, similarly this angle AOC, this is equal to pi minus B. Similarly angle BOA, this angle is pi minus C. Okay, so let us draw this again. Okay, so we have, this is the point O, this is point O. So we have, this is OA, this is OB, and this is OC. Okay, so we have the forces PQR acting along OA. So P is acting along OA, Q is acting along OB, and R is acting along OC. Okay, so we have this angle BOC is equal to pi minus A. So this is pi minus A. Similarly, this is pi minus B. Similarly, this is pi minus C. Okay, so let us apply Lami's theorem. So applying Lami's theorem, we have P upon sine of angle between Q and R is equal to Q upon sine of angle between P and R is equal to R upon sine of angle between Q and P. Okay, so this is equal to P upon angle between Q and R is pi minus A. Sine of pi minus A is equal to Q upon sine of angle between P and R is pi minus B. Sine of pi minus B is equal to R upon sine of angle between Q and P. This is pi minus C. So this is equal to P upon sine A is equal to Q upon sine B is equal to R upon sine C. So from here we have P is to Q is to R is equal to sine A is to sine B is to sine C. Okay. Okay. So we have P upon sine 2A is equal to Q upon sine 2B is equal to R upon sine 2C. Okay, and from sine rule we have, let us consider this as, this is our A B, triangle is A B and C, and we have the sides as, this side is the BC is A, this is B, this is C. So we have from sine rule we have, this is angle A, this is angle B, this is angle C. Okay, so we have sine A, we have A upon sine A. From sine rule, A upon sine A is equal to B upon sine B is equal to C upon sine C. Okay, so let us consider this as K. So from here sine A is equal to A upon K, sine B is equal to B upon K, Sin C is equal to C upon K. Okay, so let us place these values here. So we have P upon sin 2A is A upon K. A upon K is equal to Q upon B upon K is equal to R upon C upon K. So from here we have P upon A is equal to Q upon B is equal to R upon C. Okay, so this is the result that we have to show in the question. So let us discuss question number 8. Let us discuss question number 8. So we have ABC is a triangle, forces P, Q, R acting along the sides OA, OB and OC, okay, are in equilibrium. Prove that if O is the circumcenter of a triangle ABC, okay, so circumcenter of a triangle is a point that is describing the circumcircle. Okay, so let us draw a triangle. So circumcircle, so it will, the circumcenter will describe a circumcircle. Circumcenter is the point where the perpendicular bisectors intersect. Okay, so this will draw a circumcircle. Okay, so this is our circumcenter. This is A, this is B, and this is C. So let us take this as O. Okay, so we have the forces PQR acting along the lines OA, OB, and OC. So this is our OA, this is OB, this is O, this is OC. Okay, so let us consider this as angle A. Okay, so since this is angle A, so this will be angle 2A. This we have already discussed. Angle 2A, 2 times of angle A. This is 2A. Similarly, this is B, so this will be 2B. This is C, so this will be 2C. Okay, we have the forces as the force along OA is P, force along OB is Q, force along OC is R. Okay, so we have this as P, this is Q, this is R. Okay, so we have the angles as, so this is 2A, this is 2B, this is 2C. So P upon sin 2A using Lami's theorem is equal to Q upon sin 2B is equal to R upon sin 2C. So we have to show that P is to Q is to R. P is to Q is to R is equal to sin 2A is to sin 2B is to sin 2C. Okay, so let us further simplify this. This is the solution of first part. Okay, this is the solution of first part. So let us discuss question number, let us discuss question number, that is part 2. Okay, so let us further expand this. So P is to Q is to R is equal to 2 sin A cos A is equal to ratio is to 2 sin B cos B is to 2 sin C cos C. Okay, so let us place the value of sin A, sin B and sin C. So from sin rule we have A upon sin A is equal to B upon sin B. A, B, C are the sides of the triangle is equal to C upon sin C. Let us take this as K. So from here sin A is equal to A upon K, sin B is equal to B upon K and sin C is equal to C upon K. Okay, so we have P is to Q is to R is equal to 2 times of, this is A upon K into cos A. Okay, so in a triangle, suppose this is our triangle, this is A, this is B and this is C. The sides are A, B and C. So cos of A is equal to B square plus C square minus A square upon 2BC. This we have studied from the cosine rule. Into cos A is B square plus C square minus A square upon 2BC. Okay, is 2 2 times of sin b. So this is 2 times of sin b is b upon k. Okay, so we have 2 times of sin b is b upon k into cos b. So cos b is, similarly cos b we can write as cos of b is equal to a square plus c square minus b square upon 2ac. Okay, so this is a square plus c square minus b square upon 2ac is 2 sin c cos c. Okay, so sin c is equal to c upon k into 2 times of c upon k into this is cos c. Okay, so the cos c will be is equal to a square plus b square minus c square upon 2ab into a square plus b square minus c square upon 2ab. Okay, so this gets cancelled, 2 gets cancelled, and from here we can cancel out k also. Okay, so let us multiply throughout by ABC. Multiplying throughout by ABC, we get P is to Q is to R is equal to A times of ABC into upon BC, and we have this is B square plus C square minus A square. Okay, is to this is B times of ABC into A square plus C square minus B square upon AC is 2. This is C times of ABC. This is A square plus B square minus C square upon AB. Okay, so let us cancel this. BC gets cancelled, from here AC gets cancelled, from AB gets cancelled. Okay, so this is equal to P is to Q is to R is equal to A square B square plus C square minus A square times of this is B square A square plus C square minus B square is 2. This is C square A square plus B square minus C square. Okay, so this is the solution of the second part. Okay, so we have discussed up to question number 8. So we will discuss further questions in next particular lecture. Thank you.